decrease like proportionately or not really?
Does the wavelength?
Yeah, because it went from like 15 to 7.5 to 5. Is there any sort of pattern there, or is it just kind of like, I guess you just use
The same way we see here, but in reverse. So if we're adding up this with those half wavelengths, then it's going to decrease by that same amount going the other way.
So you would just change the n if you were to,
Yeah.
yeah, okay.
But it's all in this counting index right here for the n. You could rewrite the equation here for your lambda would be 2L over n, and then you could show yourself how it's going to get bigger or smaller when you're doing that. But what you're going to see is that you're dividing by the n. So you're dividing by the 1, the 2, the 3, the 4. We can't just count up halves the same way we did before, but you'll see that same decrease of the wavelength based on this here just rearranged.
Okay.
So, number 3 now has what? A piano tuner, stretching a steel wire, where now we give you the tension. Okay, so you have a steel piano wire with a tension of 800 newtons. We give you the length of the wire to be 4, or 0.4 meters. It has a tension of 800, so I'm going to call that FT instead of T now because we don't want to mix that up with the period. It's 0.4 meters long and it has a mass of 3 grams or 0.003 kilograms. Convert everything to SI units here because we need to be using those units over here in this equation for V. And we need to convert here if we want to get meters per second at the end. Okay, so what's the frequency of its fundamental mode of vibration? We'll use that language sometimes too, talk about the fundamental frequencies or the fundamental mode here. That's just referring to the fundamental frequency of vibration that we have. But those standing waves sometimes are also called modes, the different modes of vibration. We want to find that frequency of the fundamental mode and also the number of the highest harmonic that can be heard by a human. Let's go through part A here first, and I'll talk a little bit more about part B. And you have a string here that has some length. Just put this right in here, the length, which was 0.4 meters. We want the frequency of a fundamental mode. So if you want to, just show yourself this picture again for what the fundamental mode would look like. We're looking for this fundamental frequency. You have all these equations here. We know we're looking for F1. So eventually you should be thinking that you probably need to use this equation right here. So if I go here first, F1 would be 1 times V over 2L, right? If I'm looking for the fundamental, the first frequency here, the F1 would be V over 2L, where I've already plugged the 1 in to this N out here in front. Okay. Do we know the length? Yeah, do we know V? We can find V from that square root equation over there, the square root of the tension force divided by mu, which is that mass per length down here. Okay. You can do this separately if you want to and plug in the numbers. I'm just going to throw it in the equation up here. I'm going to just write the 1 over 2L and then the V, which is the square root of Ft divided by mu, where the mu is mass per length. This is F1. So the 1 over 2L is still here from before. The V I just replaced with this. If you wanted to, you could have plugged in numbers separately and just found what that was first. That's fine. I'm just doing it all in one step there. I think we know everything in here now though, right? We have the tension force, we have the mass, we have the length. Yeah, let's just plug all this in. 1 over 2 times 0.4 Up here, we have the square root of the tension force, which is 800. I'm gonna multiply by L up here, just because when you divide by that fraction there, the M over the L can be flipped up to the top here. And then our mass was 0.003 kilograms there. And then just plug all that in. And we get 408 hertz. You know, I keep telling you guys that I do my algebra this way, or I'll show it all in one step here, and you can choose however you want to do it. Some of you just plug numbers in separately for the mu, then put it into that square root of ft over the mu to get v, then you plug it in over here. That's all fine, but just like I keep saying, on the exam, all those different calculations gives you more room for error with your numbers. Plugging something in wrong, getting something wrong somewhere. In the end, I'm looking for you taking the things and putting them into the equation right here. And so sometimes you have a bunch of calculations on paper and they feel like, well, I did a whole bunch of work and I didn't get any points. All those calculations aren't worth anything if they're wrong. And time hasn't been an issue on our last couple tests because I've given you extra time. But we haven't always had that. I really don't care about the numbers separately. I am looking for this step right here. As much as you can, try to keep doing the algebra that way. Because then at least it's all there together and it shows me where your answer is. When I'm grading your exam, sometimes there's just different parts, and if you don't see how to put them all back together, then I don't see it either. And I can give you more partial credit sometimes if I'm seeing that step, because it's very clear that you're just going there. On this problem, it was just a clear two-step process maybe anyway, but when I kind of flip through your exams again, I was looking at them this morning, there's just sometimes a bunch of calculations that's just really not worth anything for all the numbers. Okay. So you plug that in, you get your F1. What would F2 be? 2 times that. What would F3 be? 3 times that. I mean, you can get those easily if you know this one right here. I didn't ask for it in the problem, but your F2 right here would just be, what is this? 816 hertz there. If you multiply that by 2, and you can get any other frequency you want once you have the first one there. Okay. Part B, I asked you, what is the number of the highest harmonic that would be heard by a human? That statement there that I have in bold text there will not always be given to you. If you have your objectives, pull those out and look at objective number 6. Number 6 says state the perceptual variables which correspond to frequency, intensity, and harmonics. We'll talk about that next time. But it says then also give the frequency range for human hearing. I've written it down for you here in this problem statement just because the first time we're talking about it, but you need to know that range of human hearing. You can hear frequencies from 20 hertz to about 20 kilohertz. It's written here in the problem statement, but from now on it won't be written in there for you. You just need to know those numbers. Okay? So that's just something that you have to memorize. I might just ask you what it is on the exam as just a question, or it could be in a problem like this where I just simply say, tell me the number of the highest harmonic that could be heard by a human. If you don't know the highest frequency that you can hear is 20,000 hertz, then you couldn't solve that part of the problem. Okay? So just make a note here that it's written here in this problem statement, but that won't be written in there for you going forward. That is something you need to know there for objective number 6. On your objectives, you might even just want to write there for that part. Put your 20 hertz to 20 kilohertz there right on your objective sheet so you know what I mean or what you need to know there for the range of human hearing. So the highest frequency heard is 20,000 hertz. From 20 hertz to 20 kilohertz is that range of human hearing. So if the highest that you could hear is this right here, how are we going to find which harmonic that is?
Divided by 8 or 408.
Because the first one is that, and Fn is equal to n times F1. But we're saying we're trying to go to this one right here, so this is going to be 20,000 hertz would be n times your F1, or 20,000 divided by the 408 would give us the n. We're just trying to find the n that corresponds to a frequency here of 20,000 hertz. Somebody plug that in for me and tell me what you get.
49.
49 point what?
01.
Okay. This here was real close to 49. Okay, and normally you would probably round that answer to 49 because that's just what the way the number would round here to be 49. But if this number here was 49.9, what would your answer be to this question?
49.
49. Right, because anything above 49.9, anything would get you above 20,000. So whenever you're doing these, don't round this like a normal number. This has to be an integer, so we know it has to be a whole number, but you have to always round that down if you're in that range here of needing to be at 20,000 or below. Even if you were at 49.9 or 8 or whatever it was, you would never round that up. Answer that, write that down as a whole number, it has to be. So the n, or the 49 harmonic here, would be the highest one that you could hear. If I asked you for the highest frequency, and this is not exactly the 20,000, but if or it's pretty close if you plugged in 49 here, but if I asked you for the highest frequency that you could hear, you would use whatever n you just found there, plug it in and see what you get. It may not always be exactly 20,000, it might be 19,975, depending on what the numbers worked out here. Here we just found the n. That was pretty much right on our 20,000 hertz, but they don't always have to be. Okay. Any questions about that there? Okay. As long as you know your diagrams and you understand the language, what we mean by these harmonics and different frequencies, the different wavelengths, this is all you need here for these standing wave problems. The set of equations over here, and an understanding of the language and what your diagrams look like. Then I think, like with this whole unit, I think you'll find if you go through the work on these, you'll find that this probably isn't as challenging as some of the ones we've done before. But you've got to know your equations. People who forget these equations or write them down wrong miss a lot of points on the exam. There isn't a lot of algebra. There aren't that many steps to some of these problems, so you just need to know your equations and your diagrams for these, and I think you can do pretty well. The median on the last test was 79, which is, that means half people are above that, half people below. The average was around 75. But I'd like to see that up in the 80 range in this next test. I really think that for some of you who haven't been doing that well, a lot of you have been doing a lot better as we've kind of progressed along, but you really should be shooting for a B or A on this test. This test is much easier to get that grade on than it will be the final, so just do your work. We're going to go to lab today, we're going to do an extra problem, but we're not going to spend all day in lab. You'll have time, I think, if you want to start doing the next homework. Get all this stuff done. As I said, I won't be here on Friday, but you can get, I think, most of this work done,